Hello and welcome to Late Night Code. My name is Ian Riley, and I'm really excited to have you join me for another problem. I'm bringing to you a solution to another problem from the Southeast Regional Contest, which took place this last February. This problem is called Streets Ahead. It is another problem in the easy category on Caddis. It's currently listed at a 1.9, and it was featured as a part of that Division 2 in the ICPC Regional. So I'm really excited. I hope that you are too, and let's go ahead and jump into the problem. So Streets Ahead. International Connecting Passage Causeway is a long rutted two-way country road crossed by streets at different points. There are many drivers and each will drive along the country road starting at some intersection and ending at some other intersection. For each driver, how many intersections will they drive through? The input contains two integers, n and q, which can go up to 10 to the 5th, where n is the number of cross streets and q is the number of drivers. Each of the next n line contains a string of at most 10 lowercase letters, representing the name of one of the streets that crosses the country road. All street names are unique. Driving along the country road in some direction, one sees these streets in exactly the order provided. Each of the next Q lines contains two strings of at most 10 lowercase letters, representing the start and end intersection for each driver. Queries will be between distinct streets, right? So then the output is output Q lines, the ith line containing the number of intersections that the ith driver drives through. Okay, fair enough. So if we were to go ahead and summarize this problem, basically they're going to give us an ordered sequence of streets. Every street has a unique name. And then what they want to do is just give us a tuple, a pair of streets, and tell us what the distance between those streets is, the number of intersections that you would cross if you're going from one to the other. So this kind of sounds like a classic hash map problem. Effectively, these streets could be associated with numbers, their position in the ordered sequence. And if they give us a tuple, what they're really asking is what is the length of this range? And they'd be giving us a range with a street name and a street name. And if we can replace those street names with a number and a number, then we'd have a range. And we could ask what the length of that range is. The other thing, though, is it's the number of intersections you cross in between. So normally, if you want to know the length of a range, you're calculating the length from an inclusive start and an exclusive end, which is end minus start. In this particular case, since we only care about the middle, it's an exclusive start and an exclusive end. So to calculate that, we do end minus start minus 1, right, to take care of that initial position. But once we understand that, then the rest of it seems pretty straightforward. So let's just go ahead and jump into our terminal and start solving the problem. I don't really think there's much more that needs to be discussed, and I don't think we need Excalidraw. So let's just go ahead and get in. So here we are in a repository with our Rusty solutions. So let's go ahead and open up our project here and go over to mod. And then let's go ahead and copy our template into source solutions, ICPC, Southeast Regional 22. And this one is called Streets Ahead. Now that that's been added, I can come up over here and just paste this below. And we'll go ahead and get Streets Ahead in there. Let's go ahead and take this one, paste that one below. Let's go ahead and get Streets Ahead, and then we can go over here and get our Streets Ahead module, call main, and then let's go ahead and open up Streets Ahead, and we're ready to start getting to work. So the first thing they told us is that we're going to be given a single line that contains n and q. So we can go ahead and say let n and q be equal to, and then we'll say let mute buffer be equal to string new, and then we'll take our IO standard in dot read line, passing in that mutable reference to the buffer and unwrapping the result. And then after that, we can go ahead and grab our n and q by setting let params, which is a vec of usize in this case, since we're using n and q to calculate usizes. Now, I say that, but we're going to be storing ins and we're going to be storing in at the very least, right, into a hash map in this particular case. And they didn't say they would be giving us the lower position first. So they might give us, for example, like a street at 4 and then a street at 2. And so we'd be doing 4 minus 2, which is fine. Or sorry, the other way, we'd be doing 2 minus 4, which will give us a negative. So I don't want that. Let's go ahead and just have these be I32s. And so now the params will be I32s, and we'll say buffer, and then we'll do a dot trim, and then we'll do a dot split on space, and then a map taking each part and then parsing it to an I32. and then unwrapping the results. And then we can go ahead and collect that into the vector and the return params 0 and params 1. Okay, that's looking pretty good. And then now the next thing is we need to go ahead and process all of our queries. So we would say for I in 0 to in, and we just need to be able to store these in a hash map. Now, if you've never used a hash map before in Rust, hash maps come from standard collections, and it effectively works like this. If you want to insert, you just use an insert, passing in the key and value. And then if you want to fetch, then you call get, which will actually return an option in this case. But they've told us that everything's unique, and they've told us that they're giving us valid queries, so we shouldn't really have to worry about this too much. So we'll go ahead and create our hash map. We create it with just the hash map new. So we can say let mute streets. We'll just call it street map, and that'll be equal to a hash map new in this case. Now it doesn't know what that is, so we do need to go ahead and say use standard collections hash map, so that way it will know. And then now we can come in here and actually grab each string. So we can say let mute buffer string new io standard in dot read line, passing in that mutable reference to the buffer, and then unwrapping the results. And then we can go ahead and say street map dot insert, and then we have our buffer as our key. It might have carriage returns since we're currently on Windows, so we should trim that. That's going to give us a string reference, so then we need to say toString, and we can pass in I. And so now we've inserted a string key, a string, capital S, and a I32. And then after that, we're now going to have queries. So for we don't care, in 0 to Q, those are our queries. We can go ahead and get our buffer, which will be our string new, IO standard in, read line, passing in the mutable reference to that buffer, unwrapping the result. In this particular case, we are going to get more than one, so we should get our streets here, which will be a vector of string, and that's going to be equal to the buffer dot trim dot map, splits on space dot map, and then each one needs to be s dot trim and toString, and then we do a collect to collect it into that vector. And then now we can go ahead and grab our start and our end. So our start is going to be our street map dot get streets of 0, passing in a reference to that, and then we're going to say unwrap. Okay. So now we've got a reference. This is I misspelled streets. There we go. And that's going to be a reference to an I32. So let's go ahead and dereference the value. And then we can go ahead and get our end, which will be here. I had it correctly. R0, R1. There we go. And so we take our street map. We get our reference to a streets at 1. We unwrap that result. And then we should just be able to print line. And then we can say here, end minus start dot abs minus 1. And so again, because we don't know the order, we'll take the start and the end. We take the absolute value of the difference, then subtract away 1 to account for the exclusive beginning. And now we can go ahead and open up a new terminal, and let's go ahead and try to test this. Now, a couple things real quick. If you're working with Windows Terminal on Windows pointed at WSL, then when you copy things into your clipboard, into your terminal, the Windows Terminal knows to actually strip off excess carriage return new lines, but Alacritty does not. So one of the things I really recommend that if you're working with Alacritty is to go ahead and install Xclip. So it's a command line tool called Xclip. Xclip is really, really useful for copying and pasting. It's also just really useful for a lot of stuff, not just transferring clipboards between Linux and Windows, which it does do, but also like it can copy entire file contents to your clipboard, paste entire things into a file. It's really, really helpful. It's so helpful that I've gone ahead and actually wrote my own bash script on top of Xclip just to simplify the tool for me. So what I can do now is I can come over to Streets Ahead, copy this to my clipboard, then I can say CLP-P, which means this is a parameter, this is my own CLI over Xclip, where I'm saying, okay, take Xclip and I want to do an Xclip paste, so it will then pass in all the necessary args. And then I can pipe that into a cargo run and then -s streets ahead. and we can see what we get here, and we get 0, 1, 0, which is in fact what we wanted. So then the next thing for us to do would be to download the data associated with Streets Ahead, which I've already done. So that data is downloaded. So now I can say quest Streets Ahead, and we are passed on all of those. So that's looking really, really promising. So let's bounce over to Caddis and go ahead and upload our file. Okay, and our solution has been accepted, and that is the solution for Streets Ahead, which makes use of hash maps in order to calculate the length of an exclusive range. So a pretty interesting problem, mostly just requires the use of hash maps. If you didn't use a hash map, then you'd have to do string comparisons, so the complexity would be a lot worse. By using a hash map, we effectively can find things in a much quicker time. So I hope that you enjoyed this one. I look forward to seeing you in the next one. But until then, have a great night.